Objective 137, students will be able to set up and solve problems using proportions. So we took a moment to talk about proportions in class, but let's do a really quick review. Hey guys, today we'll be doing Objective 137. Students will be able to set up and solve problems using proportions. So just to review a little bit, we should know what the word ratio is at this point. So a ratio is known as a rate or a fraction. We're going to go into the reason why we like working with fractions is to help us with rate problems. So it is really nice to use proportions for these types of problems. So ratios can be written three different ways. The first way we generally see it is as a fraction. So we can have A over B, right? So we're comparing one quantity over another quantity. Let's use boys and girls as an example. So the number of boys over the number of girls, or B over G, okay? Another way we can see boys versus girls, or boys over girls, is B colon G. So here we have a fraction, and here we can compare using a colon. Okay? Last way we can actually use the word two. So through our boys to girls, or 3 to 2, or something like that, right? The number of boys to the number of girls. Okay. And last, go ahead and get this definition down for proportion. If we're determining whether or not ratios form a proportion or are proportional, keep in mind this word equation. If they are proportional, then they satisfy the equation, meaning they're balanced or equal. So if they are forming a proportion, the two ratios must be equal. Again, equal is another way to say proportional. So one example that we are going to do is 1/2 equals 2/4. Notice I'm using a really basic problem just so you're getting the understanding and you're not focusing so much on the math, right? So if we look at these two fractions that are placed with an equal sign in the middle, we are indicating that these two values must be equal. Well, 1 divided by 2, that gives us 0.5. And 2 divided by 4, that also gives us 0.5. Since we have 0.5 on the side and 0.5 on the side, we clearly know, and you already probably knew, that these were equal or proportional, right? We did want to go over that there are multiple ways of going over it. So rather than you just taking the easy way out and using method 1, right? By finding decimals, you can also find equivalent fractions, which are really easy to do. By finding a common denominator, I can say that we can turn 2 into 4, and I can multiply both the denominator and numerator by 2. So 1 times 2, this gives me 2. 2 times 2, this gives me 4. So 2/4 is equal to 2/4. So I've checked it out. We're going to use that, we're going to call that method 2. Using equivalent fractions. And the last method is method 3, and you've probably heard or seen this at some point, is cross multiplication. What that's saying is when you have two fractions that equal each other, or a proportion, you can cross multiply them, meaning take the numerator of this first fraction and multiply it with the denominator of the second fraction. 1 times 4, let me show you, gives us 4. And then you take the numerator of the second fraction and multiply it with the denominator of the second fraction. 2 times 2, ooh, sorry about that. 2 times 2 gives us 4. These right here are called the cross products. And if the cross products are equal, then your two fractions are proportional. Let's go ahead and get that key point down. If the cross products are equal, then the ratios are proportional. Okay. Just to remind you, here is an example of the cross products. These are cross products. We're going to go ahead and work on example 1 together on the next page. So the question is asking, do the following ratios or fractions form a proportion? Meaning, are these equivalent? So one of the first ways that I would resort to, but again, that's not the only method that I'm going to use or that I know. The first thing that I'm going to do to figure out whether these form a proportion, meaning are these equal, is set them up equal to each other. Then the first method that I'm going to try is dividing them to see if I get the same decimal on each side of my equation. If they are balanced, then they are equal or proportional. When I divide 0.4 by 0.8, I get a result of 0.5. When I do the same on the right side, 0.7 divided by 1.4, I also get 0.5. So I've checked using decimals, or method 1, that they are proportional. Now, I'm not going to resort to this. I have multiple options, and you're not going to only have problems like these, right? So let's go ahead and see. What would we do if we wanted to get common denominators? This one is pretty tough because we're working with decimals. But we should know if we're trying to get equivalent fractions, and I'm not really sure what the greatest common or the least common multiple will be, then I can simply multiply each denominator by one another and get the same result. So I'm going to multiply this fraction by 0.8 over 0.8. And I'm going to multiply this fraction by 1.4 over 1.4. Okay? This will ensure that I get 1.12 for my denominator, right? Because I wanted them to have the same denominator for the purpose of comparing them. And then our numerators, we have 1.4 times 0.4, giving us 0.56. Then we have 0.7 times 0.8, which will also give us 0.56. By the use of equivalent fractions, we can also see that they are proportional. Now, this is a really, really important concept to understand for the sake of knowing why cross multiplication works. A lot of students want to cross multiply when they're just multiplying fractions, but you can only cross multiply when you have a proportion. So, if you notice here, and I'm going to show you these methods side by side, we are going to go ahead and start cross multiplying and see what our cross products are. So I'm going to take my numerator of my first fraction and multiply with the denominator of my second fraction. And I will get 0.4 times 1.4. I'm going to go ahead and do that the same thing. Take the second numerator with my first denominator of my first fraction, and I will get 0.8 times 0.7. These again are the cross products. Products means multiplication. We multiply it. We're going to go with the cross, so on and so forth. Now, if you look right over here, we can see that 0.4 and 1.4 are multiplied. That happens right here. We can also see that 0.8 and 0.7 get multiplied as well. And that happens right here. And since our denominators are the same already, we don't have to worry about them. They're already the same. We just have to figure out what our numerators will be. So 0.4 times 1.4, we get 0.56. And here we also get 0.56. Notice again, our denominators, since they're already the same, we just have to make sure that our numerators are also the same. This is why cross multiplication works. After a lot of practice, you will realize cross multiplication is the most efficient way to solve proportions, especially if you're trying to see if they are equivalent. So you want to ask yourself these questions. Are the cross products equal? In this case, the cross products ended up being equal, so we will answer yes. So if the cross products are equal, they are proportional. Now, we've had a similar conversation like this in class, where when we have an equation, whether it's a proportion or an equation, they're really similar. All we have to do is solve for our variable. We have a lot of different methods to solve for this now. I'm going to stick to just two of the methods, and the other ones you can try, whichever one suits you best. But one thing that I like to do is see if there's any sort of relationship. For example, I noticed 3 times 2 gives me 6. So 4 times 2 must give me 8. Okay? From there, I can double check if I did it correctly. 3 divided by 4 gives me 0.75. 6 divided by 8 gives me 0.75. They are proportional. Okay? Using cross multiplication, you should have both methods written down, so rewrite it and do it this way as well. We can go ahead and cross multiply to get 6 times 4 equals 3 times k. 24 equals 3k. Get k alone, so that k equals 8. So the entire purpose of knowing how to write ratios and solve proportions is for word problems, right? Application problems. These application problems are going to be a little bit easier, but they are going to guide us into some pretty advanced stuff. Okay? The first thing we're going to fill out is the definition of a rate. So our definition will be rate is a ratio or fraction that relates different units. So the first thing is we are going to go ahead and try writing our own rates. Here I see a salary of $35,000 per year. So I'm saying that this person earns $35,000 per year, or per 1 year. If I want to write that without the units, I just have to remember that I put money on top and I put years on bottom, and this would be 35,000 over 1. It is really, really important to write down what your units are so you know that if you placed money in the numerator, it should stay consistent in the numerator. If you put time or years in the denominator, again, it should be consistent and stay in the denominator. We are on the last problem, example 5 on page 25. We're going to do this example with you and then we'll finish it up in class. So we know that Trent goes on a 30-mile bike ride. So 30 mile, one of our units is going to be distance. He rides 30 miles every Saturday. He rides this distance, so the 30 miles, in 4 hours. Now, I know this is a rate because we are comparing 2 units. We know that they are traveling 30 miles in 4 hours. Okay? At this rate, meaning at the same rate, the rates should be equal. Right? How far can he ride in 6 hours? So when we say how far, the unknown is distance. We are trying to solve for distance. We don't know it. But we do know that he is riding for 6 hours. So we know that the number of hours or time is 6. We're going to go ahead and fill in what we know. And like I said, we want to make sure that our units are aligned. Right? If they are 100% equal, miles on top needs to go with miles on top on the other side. Hours on bottom needs to go with hours on bottom on the other side. So I'm going to go ahead and fill in my units. We don't know how far, so this is going to be X miles. And we know that this is in 6 hours. Now we are comparing 2 rates, or ratios, or fractions, with a missing variable. This is just an equation, so again, you have so many ways of solving this. I'm going to go about it using cross multiplication, and then maybe I'll do it another way as well. So 4 hours times X miles. Notice how this is getting a little bit messy. I just want to include the units so you're realizing we have to make sure that it's consistent. So I'm going to go ahead and eliminate my units. We have 30 over 4 equals X over 6. That is a little bit better. So we have 4X equals 30 times 6, which is 180. Okay. Divide this by 4. Divide this by 4. And we get X equals 4.5. Now, we know that X equals 4.5. So when we go back and look at what our units are, it was X miles. So we have to make sure that we include our units, which are miles. For today's objective, we have covered notes for pages 23, 24, and 25, but we didn't do all the problems together. So any problem that we might have skipped, please make sure you do it on your own before coming into class, and we'll continue practice together in class.